This is a 2023 JAM question, right? Question is like this. The dimension of Young modulus E is given by the expression, that is, which of these is a dimension of Young modulus. Now, before we can find the dimension of Young modulus, we need to know the relationship of Young modulus. Now, from Hooke's law, we know that Young modulus is equal to what? Stress all over strain, right? This is Young modulus, right? Now, stress is what? Force per unit area, right? Then strain is what? The extension, the ratio of the extension to what? To the original length, right? Good. Now the next thing is that we are going to replace it here and see how the equation is going to look like. So next, I'm going to have Young modulus is equal to, my stress is force per unit area divided by extension per length, right? Good. You have something like this. Now, the next thing we are going to do, let's express them. This is the same thing like saying force per unit area what divide by extension over my length, right? Mathematically, if I remove the sign of division, what am I going to do? Introduce some multiplication, right? Then flip this side. Very simple. These are basic knowledge of mathematics. So I have times L over E. Good. Now let's multiply them. So I'm going to have F L over A E. Now at this point, we are going to introduce their units now. Good. Now the unit of force is what? Kilogram meter per second square times the unit of length is what? Meter. Divide by the unit of area is what? Meter square times my extension meter as well. Good. You arrange it in this way. Now the next thing is, let's see how which one is going to cancel each other. This will cancel this, right? Good. 1m will cancel this. 1m will remain, right? Good. So what I have remaining at the top, I have kilogram, that's my mass, then per second divided by my mass. Good. Now, performing my transformation, this is the same thing as saying kilogram per second times 1 over m. Based on the law of indices, we know that if I have maybe x raised power minus 1 is the same thing as what? 1 over x, right? Good. That is the same thing we are going to apply here. That is 1 over m is the same thing as m raised to power minus 1, right? Good. Next, what we are going to have is I have what is really kilogram per second square per meter. Yes, per meter. This is what I'm going to have, right? Good. So let me substitute in. Now let me substitute using my dimension. Based on dimensional analysis, m stands for the unit of what? Based on dimensional analysis, mass is equal to what? M. That is good. My time, the dimension of time is what? T. The dimension of length is what? L, right? Good. So kilogram is a unit of what? Mass. So I'm going to have m right? Okay, the next thing is S, which is time, right? The unit of time. Then meter. Good. This is my dimension of Young modulus. All right. This can be rearranged as M, L, and this, right? This is my dimension of Young modulus. Now, our answer is option what? So our answer is option C. This is the correct answer. This is the dimension for Young modulus.